7 and 8. So what do we say the carbon cycle was yesterday? Somebody read out the definition. Okay.
Cycling of carbon and oxygen in an ecosystem, balance between photosynthesis and respiration.
All right, and what'd you say? It's the second part?
A balance between photosynthesis and respiration.
Okay, so balance between photosynthesis and respiration. Okay, so the ecosystem part is the living and the non-living parts. And I didn't really, that's what the video was trying to hit on too, was what are all the spheres that we're cycling things between? So this carbon's going from our breath out, okay? So it's going into the atmosphere from a biosphere, the living part. And then where else does it go? Can any of this carbon go into the water at all? It can't. It can. Shells, seashells are calcium carbonate.
Oh, like they don't get no seashells because they'll always be like, you see them and you'll go after them in the water.
But like the thing is that if I'm an animal that has to make a shell like that, it's made from the carbonate ions that are in the water, and they have to manufacture that shell. So carbon gets in the water too. And then when things die, think of all those organisms that die, all those shells have to fall to the ground.
Have you seen the fish?
When the waves, the little bitty fish. Minnows.
What's that have to do with shells?
Oh, I just wanted to talk.
So when those shells, when the crabs, all of those die, all this moves down like this. And then y'all talked about sedimentary rock, right? So it all gets layered up and compacted and compressed and all that stuff. So
what about like when they instead of just them dying, what if they grow out of them? They have to take the same thing. Like the shell.
Eventually, because it gets into the lithosphere at that point, and then it can be eroded and changed to the point where it can get into the water or brought back into a plant. So how many of you have ever put lime out on a yard or it's like this powdery, stuff that you can. Okay, so lime, like what we do when our grass starts to get a little weak looking, kind of not as deep green, you can throw lime out there, and that has calcium in it and carbonate in it. And what it does is it gives those roots and the plants more nutrients, and it helps them make their chlorophyll.
We can never keep our grass green in the winter, but right when summer comes, you can keep it green.
Well, and it might be because you have some Bermuda, because some of it goes dormant in the wintertime. That's why the football field looks the way it does. It's just like it's hibernating. And then once it gets warmer, you'll start to see they'll start producing chlorophyll. So there's some things they have to do to it to make sure that it does do that well. But anyway, so the next thing we wrote down was photosynthesis, right?
Yeah.
Okay. So tell me, what are the reactants of photosynthesis? Tell me one more time without looking. What has to come into the tree? Okay, so we said light.
6 H2O.
Plus 6 waters.
6 carbon.
Carbon what's? Right, because there's different carbon compounds, so we have to say that gas. Now, what are the products? Because we said these are the reactants. They are added together.
Glucose.
All right, so what is the formula for glucose?
C6H12O6. Trying to get it out.
Okay, so 6 plus, all right, so it's one of those and 6 oxygen. Okay. So the opposite of that, so here's some carbon going in used to make the food we eat. So when we breathe out a waste product, we're kind of giving ourselves food.
That we breathe, feed ourselves.
So think about it. It's kind of weird, isn't it? And then we find out, when you water a plant, the sun actually splits that water in that leaf. And when they split it, we get oxygen. So you're really giving yourself oxygen when you water a plant.
So basically taking care of yourself by taking care of something else.
Because it's 2 cycles that depend on each other. is a coupled reaction. They're like a couple. They all both depend on each other, and the first part of one is going to be the opposite of the second part of the other. So tell me what you're taking in, or what did you take in as your food?
Oxygen.
Okay, you breathe in oxygen, and then what's your food molecule? Glucose. Okay, so see how what we ended up here goes in the front of this one. So one glucose, but you'll be eating a whole bunch at one time. You don't just take like one little one. And you breathe in a whole bunch of oxygen, even though it only takes 6 to help convert this to these products. So the reactants of one are the products of the other. Okay, so what are you breathing out? 2 things. What are you exhaling?
Carbon dioxide.
And if you fill your hand and breathe on your hand,
H2O.
water.
Carbon
Right.
dioxide and H2O.
So you're breathing out both.
So basically, it's just back and forth. That's basically what just happened.
But we're missing something. And this wasn't in our diagram. What's the whole point of this whole process? If this is, what is this being converted to? What energy that your cells need? What do you have to keep?
ATP.
Right. So you remember on the cycle, we said you have to get glucose from your food to feed the system? That's why. So you get up to 38 ATP from one glucose, which is a lot. So you eat something really starchy. Starch has just thousands of glucose molecules. You can eat a French fry, get a whole bunch of glucose molecules. You're going to get a whole bunch of energy. But if I was going to eat, like I ate a Reese's peanut butter cup yesterday, it was good. It was really good. But it has lots of fat in it too. So when I look at fat, like those jelly beans I had yesterday, there's no fat in those. It's just a bunch of glucose. But that candy bar had chocolate, which had a lot of fat. But fat gives us a ton of glucose. So it's a lot of energy in it.
A lot of energy.
I did from that. I sure did. I loved every minute of it. So when we draw this diagram, that's what we're going to act out in just a minute. Okay. Now, going back to it, I want you to tell me, these are balanced. That's why we had to put the 6s and all that stuff. Are these completely balanced? Like, do you see 6 waters here and you see 6 waters here? Like, just compare it and see if you see anything different.
The light to light.
All right, the light and what else?
That's about it, probably. And the ATP.
And ATP. Okay, so if you take this energy and this energy, everything else should be the same, right?
Well,
So
that's
that's-
energy is exactly the same.
Right, it's just a different source. So isn't this completely balanced?
Yes.
Okay, so humans screw it up. We screw it up when we burn fossil fuels. So do you remember what you add extra to the atmosphere? That's a greenhouse gas. When you burn fossil fuels, extra carbon dioxide. And there's some other junk too. I mean, anytime you burn anything, if you burn a piece of wood, you're going to get other stuff that goes into the atmosphere. But carbon dioxide is the major one. So kind of screw up the balance. So sometimes. All right, so tell me what to draw. So here's my little tree. I won't do all the colors. All right, so one more time. What's going to start the process?
Light.
All right, so when we go outside in a minute, whoever's the sun, you're going to start it off. And I'm going to narrate the first time, and then we'll get 2 other people to narrate. And then I'll take your parts. So the sun, we're going to say, sun's going to shine on that plant, and the chlorophyll traps the light. And that's why I wanted to show the color, because if there are no leaves on that tree right now that are green, it's not doing any photosynthesis. None. It's asleep like a bear in the woods. It is hibernating, it's dormant, it's not doing it because it can't trap any sunlight. But if any plant has any green parts of it, it could be doing some photosynthesis. So it has to trap the sunlight.
So it
So
has any chloride.
right, because leaves are the photosynthetic organ of most plants. Okay? All right, so what happens next? What has to come up through the roots?
Water.
How many?
6.
William, don't say anything anymore.
Okay.
So 6 waters come up. You're doing a fabulous job. So how many? So what's next? Need some carbon dioxide. Okay. So I drew this little blob over here, and I said this was roadkill or some dead animal. Outside I wrote roadkill. And there's bacteria decomposing the roadkill. And they're using oxygen too, but they're releasing carbon dioxide. And this person over here, yeah, is releasing CO2. So I drew 6 of those arrows. So I'm just going to show 4 more coming in. So 6 CO2s go in. How do they get inside of a tree? They don't have a nostril. They don't have a mouth. How do they get inside of it? The leaves. So second period, what we did is, that's why the thing's open, is they didn't close it back, is that they took a microscope and I said, go get a leaf off a tree. And we looked for the nostrils of a leaf. So if we take a leaf and look at it under the microscope, the bottom of it has little holes. And they have these little cells. So we're actually going to talk about that, not today, but we're going to do it, I guess it'll be tomorrow. We'll talk more about photosynthesis. But they have these little holes, and they open and close and open and close, just like you suck in your nostrils, and this closes and it opens and it closes and it opens. And that's how it gets it in and out. So we're done with this part. So what's going to be made?
Oh, glucose.
Somebody else tell me. What's the sugar? Glucose. Where is it?
It's the top.
It could be in these leaves, but we're not going to sit there and just pick and eat apple leaves. But we're going to eat the fruit because it's tastes a lot better. So let's say this guy picked this butterfly-looking apple. So that's glucose, and it's going to be a bunch of fructose too. Okay, what else are we going to get from it? What gas? Is there waste? O2, right. So oxygen comes out. Oxygen comes out. So I'll just say 4 more come out. So a total of 6. So I'll narrate what's going on out there. This is in perfect balance. But this is what you need to do to your diagram. We have to draw a factory and a car. Okay? So draw like some little factory and like some little car. I'm not very good at this, drawing cars. I'm going to put fossil fuels. I'm going to put FF on that car too. So if we put fossil fuels in those cars, what extra gas are they releasing, we said? Yeah. So extra, or the word excess, CO2. And this is what's going to lead to, they call it, it's not global warming. I mean, it's not the greenhouse effects. The greenhouse effects is what keeps us nice and warm, like the normal, natural way. But they call this global warming or global climate change. Did Dr. Curry or Ms. Bostick call it climate change? Yeah. It seems to be a little bit more politically correct. Okay, so global warming or climate change. Okay. So this traps heat. So what I would describe it as is like you get cold, you add like another blanket on your body, and you can feel when it's really cold, and then like in a cold room, and you put that blanket, and you can just feel the heat like getting trapped. Because you can really feel it when you take the blanket off and all the heat goes away. Mm-hmm. So if you trap the heat, that's normal. But let's say that you burn some fossil fuels, it's like adding another blanket and then another blanket. And now you're starting to sweat because you have all this heat's being trapped. That's what it is. That's exactly what it's like when you add all this extra CO2. So now we're getting what's happening to the ice caps. Melting. And the glaciers starting to melt.
But what's weird, now I found this kind of weird. The North Pole's decreasing, but what's weird is the South Pole is increasing.
Well, I don't know.
I've noticed that.
Well, I know that
I checked on a map and noticed it a little bit. Some
of the big, huge glaciers, though, are starting to fracture and break. So, and then what happens to the sea level?
It's mostly on the north, though.
2/3 of the world's population lives within 100 miles of a coastline. 2/3 of the world's population. So think about it. If the ocean continues, the sea levels continue to rise. Think about how many people are going to lose their homes and lose civil. I mean, literally, think about New Orleans. It's like at or below sea level. I mean, it's ridiculous. So I don't know. It's going to be a very scary thing. A lot of habitat loss. So that is the carbon cycle, and that's what we're going to act out. So I'll give y'all some parts. We don't have, I think for everybody that's here, some of you might just have to like hold 2 of the same thing, just kind of like I did that for CO2. Yeah, just let that one get. So y'all, let's see, I need an apple. Somebody has to be the apple. Somebody has to be the sun. You have to wear this.
I'm the sun. That's me.
We were going to do it 3 times. You have to change. All right, water.
What you want to do?
Oxygen. He's got sunburn.
He said that's what he was
He is a sunspot.
You shouldn't have played with this game, slave.
That's cool. That's very cool. I like that a lot. See, I don't even know who they are yet, but juniors.
Oh, yeah.
Junior
Back in the building, you should have stayed in the
10, or do I can do number 11.
Okay.
The 11.
What you doing in here,
Like they're going to leave.
Mr. Alvin?
Wait, everybody, there's a lot of stuff on desk. Y'all have to grab something because we're going outside to do this.
Stayed in
So
the
grab
lane,
one.
stayed
You might have to
in
grab
the
2 of the same thing if we don't have it. Yeah, I like that.
What you doing in here, dude? Why you in here? What you doing in here? Next period, I see. I just did mine.
Oh, your engineer thing?
Yep.
Okay, so what you're going to do
Oh.
With the parts.
is.
They're all mechanical parts, bro.
All right, so you. All right, so you're gonna be the person standing out there in that.
Should've stayed in your lane, stayed in your lane. Should've played with the game. It's time to make the stay, but he was where she was. Cause she didn't come to school for about 2 weeks. But you was not O2, boy, your breath hot. Yeah.
What, oxygen?
Take that pill. Take that pill today. Oh. Oh, we on that live, you heard me. We on that live up here, you heard me?
All right, come on.
Stay in the game, stay in the game. Hey. I'm on the top of the mountain.
What was he at school again? Marley, quit drinking my stuff. You don't know how to do something.
Yeah.
He's ATP. You should have made ATP.
Yeah, really. Okay, so just put the sign, let's break the stat right there. All right, so let's see, let's start with, everybody get 4 different colors, doesn't matter. 4 different colors. So there's a little stack right over there.
What are we coloring now?
We're gonna do our food webs, food change, because that'll bring us to our activity. So everybody, we're gonna end up needing 12 colors, but you'll start with 4 and you can rotate around. So how organisms get.
What time is it now?
Right, it's about right.
Oh, so cold out there.
Oh, please. I'll give him back.
No.
Oh my God.
Where do you go? Where do you go? Over there.
That's it.
Okay.
What colors we need?
Come on.
I'm asking her for some colors.
You've got some right there. All right, so we're gonna go ahead and start, y'all.
How many colors?
Okay, so next thing underneath when you wrote the carbon cycle, how organisms get their energy.
Where you running from, bro?
It's called going up and down.
You should have stayed in your lane. Play with. Sorry, 12:40.
All right, so how organisms get their energy. You got 2 options. What are the 2 options?
Robin, that is Robin.
What are the 2 options with how an organism gets their energy?
Producing or eating.
Right, so producing it or consuming it. So we've got autotroph.
But you could have just asked for that.
Heterotroph. Now, when we do this, when we do this, we're going to list vocabulary. If you already know the definition of the word, you know how to describe it, then you don't have to write out a definition. Okay. I would only write out what you don't know. Okay. So a lot of this stuff is just review. So autotrophs are also known as producers, and they start food chains, right? So they're the ones who harvest the sun's energy. It was that tree out there who was able to photosynthesize. So start all food chains. All right. And AKA consumers. And they depend on everybody else for their energy. Okay, so what are our options? If you're an autotroph, who are we talking about? Which kingdoms of organisms have autotrophs in them? All right, plants, plantae. Who else? Who's not a plant, but who produces? Who is another producer that we just said earlier? Who are the producers of the water of aquatic ecosystems? Which protists? So plants and algae. There's also cyanobacteria. So those blue-green bacteria are the first on the planet. So if you don't remember that, I would write it. If you remember it, I wouldn't worry about it. So plants, algae, and blue-green bacteria, which are cyanobacteria. And that was the third one that they mentioned on that little video earlier. Okay, so and they still exist, but they're the current cyanobacteria were the first autotrophs, or their ancestors were the first that were on the planet. Okay, so heterotrophs, you already know all animals, all fungus, because they eat what they grow on. And then your protozoa, like your amoeba, those are protists that are animal-like, right? And then some bacteria. So that's those are photoautotrophs. That's who we're talking about. So where do they get their energy from? What is photo? The sun, light. Okay, so that's good enough. Huh?
All autotrophs are basically plants.
Well, they're examples, but algae are different because they're not considered a plant. They're considered a protist. All right, so under the heterotroph, what we're going to do is just list what are your options and get your food, okay? So if you're a herbivore, what are you eating only? Plants or other autotrophs. So if I am an algae eater in an aquarium, I'm a herbivore. So it doesn't have to be a rabbit or a cow or a grasshopper. It could be something in an aquatic ecosystem that eats like algae. So a herbivore only. So what are you if you're a carnivore? Or the flesh of another consumer. So you don't have to be like a bloodthirsty lion. But if you're only going to depend on another consumer, let's say technically, if you ate mushrooms all day, you'd be a carnivore.
It's so nasty.
Really? But think about it. But you're eating not plants, but you're eating consumers. So, some bacteria. All right. How about omnivore? That is both. So you have a varied diet. So now let's talk about adaptations real quick. Which of these would have the pointiest, sharpest teeth?
Carnivore.
Exactly. Okay, so who would have some sharp teeth but some flat teeth?
Omnivores.
And that's ours. If you look in your mouth, you've got that. Some sharp in the front, flat in the back. Herbivores?
Yeah, flat teeth.
Yeah, and that's why they're all,
Some don't even have teeth.
true. Right, okay. Now, the next one is parasites.
Ain't that
Rely on something else.
Okay, so parasites that we may encounter: mosquitoes, ticks, fleas, bed bugs, tapeworms.
They hurt what they like.
Ew, tapeworms.
It's like unhelpful. It's a one way to
Nah, I ain't human.
So, what are all those having?
Parasite.
What do they all have in common?
They're all bugs.
No.
They all rely on you.
Okay, so they all rely on a living host, right? So, let's put food from a living host. Okay, so if I'm a parasite, I don't really want to hurt my host. but you know, I could, but I don't want to hurt them because why? You won't have any food left. That's right. So one of the homework questions for my second period class today was, how in the world do parasites know where to get their food? I mean, mosquitoes don't have that great of eyesight. How do they know you're there? They can detect your CO2. So how they know if there's a bed bug that's in your mattress and you are lying down, hold on for a second. You're not doing anything but sleeping, but your breath, because you're releasing CO2, it can detect that CO2. It also can detect the warmth of your body.
You can make them go away.
I heard that mosquitoes were like,
I mean, if it's hot,
if you're like something, never mind.
Well, the females, usually it's the females that are the biters. You
What the
know,
males? What the males do?
they're not those. So, all right, so food chain, real quick. So let's do a food chain.
Girls?
Yep.
Man, we killing girls? That's messed up.
A one-way flow of energy in a community from producer to consumer.
what we on the food chain?
Yep. And then I left somebody off up here. Who eats all the dead stuff?
Scavengers.
Scavengers and decomposers. So they're called detrivores. Mm-hmm. So detra, dead stuff, detritus, old like dead cast-offs. So you're a scavenger or a decomposer. So who are the major decomposers on the planet?
Crows.
The decomposers. The vultures are good scavengers, but who breaks down and returns all your matter to the earth? Fungi and who else?
Algae.
Bacteria. Yeah, so fungi and bacteria is who does most of that cycling of nutrients. Now we know there are earthworms and there's like maggots and there's other animals that kind of do that too. But that's part of their job, so they can eat dead stuff. Okay, so let's do a food chain real quick, and then we're going to jump into an activity. So let's just do one easy one. Grasshopper. Let's say it's a bullfrog. Oh, yeah, water snake.
Did you say a water snake?
That's like what I have in that jar over there.
What? Where? Oh, that's the one in there.
Okay,
That kind of made me not want to go back to the lake.
so tell me what the trophic levels are. Trophic, water snake. So what are the trophic levels?
Trophic levels.
Troph means feed. So if I'm an autotroph, I'm a self-feeder. If I'm a heterotroph, I'm an other kind of feeder. I depend on somebody other than that.
I have a question.
So these are your feeding levels.
Do snakes mean to hurt us?
No, they're scavengers. You heard that before.
Yeah. Snakes also mean.
No, not usually.
That's my cousin. Katie.
All right, so y'all tell me your food chain real quick, or your trophic levels.
It's auto, hetero.
All right, so what is the producer? Grass. So producers, we said start them off. Sometimes you'll see primary producer, but we're just going to say the producer. Okay. So who is this? So that is a primary or 1 degree mark consumer. Okay, so primary consumer. All right, so what would we call the bullfrog? Secondary, right. So a second level or secondary consumer. Second.
Come on, man.
And then a third level is tertiary. I'm just going to put 3C. And here's the word. Okay, so a tertiary consumer. And then you have a 4C or whoever's at the very top. So what did they say in the video about the energy transfer. We know it's one-way flow. You don't like say, hey, I'm going to give you some energy back to the grass. I mean, you know, it's all one-way flow. How much is passed on? 10%. So 10% is passed on to each level, which is not good.
Why shouldn't it be 10%, 20%, 30%, 20%?
Well, this is how it works. So if the grass has 1,000 calories of energy, 10% of 1,000 is what? The grasshopper only gets 100 calories out of that grass. So 90% of it mainly is used by the grass and really goes out as heat. So what's 10% of 100?
Yeah.
And then what's 10% of that?
One.
So look who doesn't get a lot of energy out of the food they eat. So you might be the big bad predator, but you don't get jack out of the energy that you, or out of the food that you eat. So who really gets the most out of what they eat? Which consumer?
The secondaries.
10? Yeah, so here's your argument for people that want to be vegetarians. You know, there's a whole lot, they get more energy. If you're out here being a big old bad meat eater all the time, you're really not getting as much. You have to eat a little bit more, but you have to eat more in order to get the same amount of energy. So it's kind of a different way of thinking about it. So what we're going to do is you're going to make a food web. Okay, so on the cover, does everybody have a packet? Because I'm going to shut this down so I can show you how to do it. So, so everybody have the new packet. On the cover of the new packet, they got passed around. That's your activity. So you can really put everything else up except that packet and like some colored pencils and something to write with.
Miss Thornhill.
All right, so did y'all get one? Okay. Did you get one?
Miss Thornhill every time she has a packet, I never get one. I didn't get one again.
Oh. Here you go. Let's start.
What's the difference between one of the
Food
Okay.
Web's more expanded.
Okay, so that's what we're going to do. So I'm going to write the food chains up on the board. Y'all don't copy these, but these are all the different food chains that you're going to put together to make a food web. Okay. All right. So a food web is realistic. If I am only eating one thing for my entire life, only one thing, then I would only be a part of one food chain. Y'all think about that. If you eat a slice of pizza, they'll say it's cheese pizza. Well, there's lots of different food chains. There's the wheat in you. There is the grass cow in you because of the cheese. There's the sauce, so it's you and a tomato. It's you and sugar. Think of all the different separate food chains in one piece of pizza. So it's really a lot. So that's what a food web is it's realistic. So what are some of all the different ways that who eats who and who gets energy and who depends on who for food? And that's what this shows. So so here we go. Where do you find who's the only producer? I want you to look at all the circles. Who's the only producer in this food web?
Plants.
All right, so you just answered the very first question. So look below where it says identify the primary producer. You just write that out to the side.
Plants.
So that means that's where every one of your food chains is going to start. And it's going to eventually look, you have to try to keep it as neat as you can, but it's going to be going everywhere because there's going to be all these different food chains. So that's why you only have 4 colors. You're going to end up needing 12 different ones. So you'll just kind of pass them around and you can get others. So here we go. So here's the food chains.
Here we go.
All right, so the very first one is plant parts. And I'm just going to put PP from here on out. But plant parts, mouse, and snake.
She said it on top.
No,
Come on, girl.
an owl. Okay, so this is the first of 12. So what you will do is you'll take one color per food chain. So take your first color, go ahead and find plant parts, and you have to draw an arrow to mouse with that one color.
Yeah.
Okay.
See the green.
And then you're going to draw an arrow from the mouse to the snake because the mouse is going into the snake's mouth.
Where parts the mouse?
And then the snake is going to go inside the owl's mouth.
Use the same color for
Same color for that
Snake
one.
all the way over there.
Yep. So,
And the owl all the way down.
snake.
so I'm just going to continue. But after you get the first one, switch up colors, and you'll do each one. But you make sure you're not doing this though. Don't draw lines like that because we don't know who eats who.
Dang it.
So the arrowhead has to touch whatever's eating it.
Dang it.
Okay. So just make arrowheads. Okay, you can fix it. All right, here we go. Just what plant parts
The mouse, he's eaten by the snake.
is
All insects.
raccoon.
That part's the mouse. Mouse the snake. It's what the owl. Oh.
Where's my hole?
Where are we going? Oh, to the owl.
Oh, for Jesus.
This a new one?
Oh, not Hulk. Sorry. Let's see.
Mr. Owl. So now we're going to plant parts to raccoon. Where's the raccoon name? Okay, straight across.
Straight wrong.
I find that it's easier for you to make this as I write it because when I just put up the list, people get, if you don't have it in front of you, you can get kind of lost. So,
Plant parts,
Alright.
raccoon, snake.
so small insects.
Plant parts, raccoon, snake. Arrowheads.
Yeah, snake and hole.
Come on now. Down there to the hole. She said how she supposed to get to the hole.
So
Yeah,
this
all you gotta do is curve down.
on through.
Alright, next color. We're gonna get that green. After you're done.
See that? See that? Arrowhead.
Oh, you got a yellow. Still like this. Plant parts. Earthworm, robin.
Plant parts, raccoon, snake.
Robin.
Hulk.
Robin.
Plant parts, earthworm.
Snake.
You said we gotta use different colors, right? Oh, each one.
Mhm.
Okay. We need to get called Earl.
We'll get that one. We can get that.
Oh, Earl got one.
Plants.
I already used pink. So now we're going to plant parts to earthworm.
Raccoon.
What is that?
Snake.
Okay.
Raccoon.
Yes,
Snake.
yeah. Let's see how we get there. Alright, earthworm. Then we got the robins.
Can I move that one up? Everybody's good with the top, right? Is everybody good with number 2?
Yeah.
All right, so that is the 3rd, 4th, 5th, 6th, and 7th.
I think I got myself mixed up.
Oh. What you got over there?
It don't matter.
It does because you get 5 points for every one you get right.
So earthworm,
Don't count
robin,
me.
You're on what
snake, small
number? What number are
insects,
you on?
plant parts.
Can I go sharpen this?
I'm on the black one.
Okay, with Robin. So what color are you?
I should use that.
All right, so you've done raccoon.
Sparrow, fox.
Wait, are you on this one right here? Earthworm? Okay, why don't you use yellow?
Red.
Right here.
No, you use yellow.
Oh,
So yellow's not even here. You want to use one color for each one. So here, let's do this. Since you, is this the earthworm, the robin, the snake?
Why I gotta keep doing the
So,
small insects, raccoon, snake? Okay, I was right.
Sparrow.
so what you want to do is you got to use one color for the entire thing. So like, Like the berry, so this one,
Snail.
earthworm, robin, snake.
Next way, it sort of did a little bit.
Yeah, we have to, let's fix it. I'll start, keep that one for the earthworm.
Sandra, can I use blue chunky?
Snail.
Oh yeah, I was gonna say,
Cannot be distracted.
Ow. Oh. What cricket? Cricket got no look.
oh, it will. Okay, so take your brown, this is, we're gonna have to check these, but, so it goes earthworm to robin, so now take still the brown, and go from earthworm to robin. Okay, and let's do this.
This is cricket.
Now, the robin is eaten by the snake, so now draw it to the snake. And you're done with that one. Okay, so that's number 3. Now check your number 2.
Then the cricket don't show no love. Wow.
All right, so check your mouse, snake, owl.
Hey, can you give it to Sandra?
So this is orange.
Thank you.
Mouse, snake. So take your orange, yeah, go to snake.
Miss Thornhill.
Hold on 1 second, owl. So you have to go all the way down to owl, that's this red one. So now go down this, you see, I think you trained it. So this should already be orange. Yeah, go down to your owl, and then,
Rabbit, snake, hawk.
okay, so now do raccoon. So you've got landmarks of raccoon, and then you have to go snake. So go
Rabbit,
to snake.
snake.
The same color, I guess, because you use this. We'll have to
You see
do
what
the
the
same
cricket
color.
on there?
Go to snake,
You see
and then do hawk,
Hey, you can record.
and then go. Then make this an
Why
orange.
wouldn't you go to the cricket?
I'm sure
All
you
right, now
did.
you're ready. Now you're ready to do number 4. Now. Okay, so.
We
that's
missing one.
The cricket.
Why we ain't go to the cricket?
We have 12 of them. Yeah, there's 12 total.
No, it's not. 3, 6.
There's 14. Oops. Cricket.
Cricket. And then it is.
I need one more color.
Oh. Mouse, owl.
Rabbit. Let's see.
Cricket.
Cricket. Mouse.
And I can use the radio. Great. Thank you.
Cricket,
And I'll just stop until, is everybody good for number 4 and 5?
No, I need 5.
Okay, I'm just gonna move 4. Have you done 4, right?
Yeah.
Okay.
Can I use the pen? Oh, now I got pink. Never mind.
Yeah, just trade around. There should be some.
I need that light blue.
Here's a purple highlighter and a pink highlighter. Somebody needs those.
Can I use that purple?
Oh, you have this good pen. I love those. All right, let's see. Do I need a pink highlighter?
Rabbit hole.
I got all of them.
Here's a purple.
I already used
Okay,
first.
this way supposed to look.
What if we already used the color?
Yeah, 2 more.
One more.
At least-
Normally we do
Let
14,
me see that
but we're
black
only doing
circle.
12. We're gonna stop.
Hey, G,
All right, so I gotta get
let me
my
see that black box.
Diane, what color you use?
Dara, let me see the black.
fox. Okay, I got my fox. Snail. And the raccoon.
And I got gold color. What are you using? What's another color that I bought that you use? Let me use it.
Delio. Wait.
Okay.
So I got number 5.
Yes, I just need 7, 8, 9.
Benjamin, you have 5. Parts. And then it is. Already did small insect tracking. Got.
This story piece of pencil.
You can use a pencil.
Okay. Earthworm, snail, mouse, snake. Look at that. Earthworm.
Where is Earthworm?
Okay, got that. Snail, mouse, snake.
Wait,
Coding.
6.
I mean, not even coding, but
Say no, sir.
look, you see how it's going
Wait,
around.
7.
I'm trying to think. What's my last one? I'm missing one.
Earthworm.
PP. Plant. Snail. Mouse. Snake. Okay.
You said plant, snail.
Snail.
That was short.
What's 7?
Meaning that
I didn't get 7.
Okay, so once you have 12 of them, you know, because you can count 12 lines leaving plant parts. So if you go around and you count 12 different ones that have left plant parts, then you will automatically have 70 points because it's 12 times 5. No, 60 points, I'm sorry. 60 points. And then the rest of the points come from the answers to the questions. Okay, so I'll show you how that works. It's pretty simple.
I got 12.
At first it's a little 7. There.
Yeah, I got 12.
Okay.
Awesome. Let's go ahead.
Yeah. Looks a little crazy, doesn't it?
Like the artwork.
So one way we were going to do this is I'll give give everybody their own name tag of one of these, and we were going to throw the yarn around, and you create the web in the room.
Oh, yeah, maybe that. Come on, bro.
Let's do that.
Dang it.
Because you need to scan the yarn so you can throw it, you know?
Let's do that tomorrow then.
Maybe we could do it as we're
I don't
doing
even
it.
know. Give it tomorrow.
Yeah.
You
Right.
need
Okay, so this is what you're going to start to do. And you can start doing it right here, and then we'll have to move the board up. Now it's time to answer the questions down below and on the back. Okay, so you have to identify, if you've already identified the producer, where did they all start again?
Plant parts.
Plant parts. So that's easy. We have one producer. But now you have to list all the consumers, primary consumers, first consumers, but you only have to list them once. So like if you see mouse there twice, like I see rabbit twice, you only have to write rabbit one time. Okay, so I'll move it up, but look at all, and you can actually do it off of yours, you know, and go around. But you can also look up here. Okay, so you get a point for every one of these that you get right. Where's your stuff?
Come on, girl.
You a neck. Oh, you a neck now.
Alright, so you already done.
You can't even get down. I can walk without a fall.
You don't know when they crap. Ready to take a nap.
Okay,
You just make me try hard.
you're good. I know you're done.
I'm done.
Alright, so now it's time to do the bottom part.
I already did. It's plant parts, primary consumers, girls.
I got it. Earl. I got it.
All right, so let's start doing the primary consumers. So who are the primary consumers?
Rabbit hawk,
So what are they always going to eat?
plants.
Or the producer, whoever's the very first one. So start listing them, and then I'll go up on the board.
So,
Okay. So you said mouse.
mouse is primary consumer.
Yeah, you can't even get down.
The mouse is
I can walk without a fall.
Okay. And you're going to list each one of them, but only one time. If they're listed more than once, you
So
only have to
what
do
you
one.
say? You said mouse.
All right, so you just go ahead and fill them in, see what you think.
a rabbit.
And then I'll move it up the rest of the way. Okay.
This looks like a lot of mess.
There's only 8. Wait.
And there's no there's any more.
So the first and the last were both mouse, right? So you only have to write mouse once. So I'm going to move past that one. All right, see if there's any others, primary consumers that you haven't already listed. And then you're going to go to the secondary consumers.
How's the right between the primary and secondary?
Because it's a big dog.
Oh, big dog.
7.
And a mouse.
This ain't what you want. This ain't what you want.
Okay.
There's only 1, 2, 3,
You know.
6. There's only 6 secondary.
Different ones.
Item number 9. Or no, number 10.
Okay. All right, so go to your secondaries. So Dara, you got all your secondaries listed too?
Not yet, still looking.
Well, come on, get to it. Okay, so this is where people will get confused. They'll say, what's the secondary consumer? And folks want to count this. And they go, oh, the second one, 1, 2. That's not the secondary consumer, right? So you don't look there. Look at the next one. So secondaries ate the primaries.
Right there. I don't know if I saw all this last I don't know if I saw Robin's last time. This one.
All right, so homework. Let me show you what you got. Yes, Jen?
No. I got a little thirsty. You should have taken it.
Okay, so the homework questions are, I don't want to do any of
I didn't
these.
hear you.
All right, listen. I mean, we can do a pop quiz and hold it against you anyway. Oh, all right. Oh, okay, then you not have it. The back of this sheet, not this one, but the back of this sheet.
I prefer pop quiz.
That one.
Be quiet,
That.
Benjamin.
Send it in that remind thing.
9 through 16.
So the back of the second sheet.
That one.
Can you
Right?
send it in the remind you been
It's 9 through 16.
No,